Hi, I made this video and forgot to turn my mic on. I hated my hair right there, so I tried to fix it. I gave up. I pointed out that this part of the ACT, you might not feel like you know how to try very many of the questions, and that's okay because we're going to be working 41 through 50. And again, sorry about that, but I'm just going to voice over it. I don't remember what all I said, but I'm just going to lay down this audio track. So in the first problem, there's a frequency chart, and it shows the cumulative number of Miss Hernandez's science students whose test scores fell within a certain score range. All test scores are whole numbers, and then there's a table. How many students have a test score in the interval 71 to 80? And the first thing I'm really trying to do is get you to look at how to even read a cumulative frequency chart that from 65 to 70 is 12, 65 80s to 13. That means there's only one more person in that second group than was in the first group. And that's why the answer is going to end up being A. On 42, the number of decibels D produced by an audio source can be modeled by the equation D equals 10 times logarithm of the quantity I over K, where I is the sound intensity of the audio source and K is constant. How many decibels are produced by an audio source whose sound intensity is 1,000 times the value of K? I point out that they're trying to scare you with this problem with the use of a logarithm. They know that it's like very much an Algebra 2 topic that not even necessarily everyone has seen yet. So if you do understand the basic idea of a logarithm, we can try this problem. I'm copying the formula onto the other piece of paper. The last part talks about how the sound intensity is 1,000 times the value of K, but they don't give you the value of K, so all you can really say is that I is 1,000 times K. And that means that the part inside the parentheses is going to be 1,000 K over K. The K's are going to cancel, and it's just going to be 1,000. And then a base 10 logarithm is about powers of 10. So if there is no number there, it's assumed to be 10. And I do an example to show you that, base 10 logarithm of 100 is 2 because 10 to the second power is 2. And I point out that you can just count the zeros as a shortcut. So that makes all of that 3 that you need to multiply by 10 and get 30, which is choice G. 43. Mario plays basketball on a town league team. The table below gives Mario's scoring statistics for last season. How many points did Mario score playing basketball last season? And then there's a table. So total points. Probably pointing out that the 3 columns are the type of shot, which is the number of points it's worth. The second column is how many they attempted. And then the third column is a percent successful, which I've switched to a decimal. So you really need to do these 3 extended multiplications from the table to figure out the number of points that they've scored of each type, and then you would add those up. And then I think it's sort of at the bottom, yep. And I'm talking about the 0.25 is a quarter, and a quarter of 60 is 15, and 3 times 15 is 45. and that 9 times 6 is 54. So 90% of 60 is 54. So that's 108 points because it's worth 2 each. And that 0.75 is 3/4. 3/4 of 80 is 60 times 1. That's going to be a little over 100 plus a little over 100. So it's a little over 200. It's 200 something. And if you look at the choices, choice C is 213. That's the only one that's a little bit over 200. So you're finished even if you don't actually add up the numbers. 44, the graph of y equals absolute value x minus 6 in the standard xy coordinate plane. There's that phrase again. Which of the following transformations, when applied to the graph of y equals absolute value of x, results in the graph of y equals absolute value of x minus 6? So this is also kind of very much an Algebra 2 problem. It's about functions and transformations, and they're hoping you don't know fast ways. I'm reminding you that the graph of absolute value looks like a V with the point of the V at 0, 0. And then thinking about the other one they wanted us to talk about, I point out that x equals 6 would make that 0. And so this actually is still the same V, it's just now the point of the V so that it's going to output 0 would be not at 0, 0, but at 6, 0. So the graph looks something like that now. So how do you change the top graph? To get the bottom graph, you move it right 6. And that's just translation right 6. If you wanted up and down, the addition or subtraction would have been outside of the absolute value. The reflection, really what might matter there is if you put a negative in front of the whole thing, it would flip the V over and make it upside down. 45. Toby wants to find the volume of a solid toy soldier. He fills a rectangular container 8 centimeters long, 6 centimeters wide, and 10 centimeters high with water to a depth of 4 centimeters. Toby totally submerges the toy soldier in the water. The height of the water in the submerged toy soldier is 6.6 centimeters. Which of the following is closest to the volume in cubic centimeters of the toy soldier? So you establish the height of the container and you really only fill it to 4. So at the start, the actual volume would only care about the height being 4. And then I'm probably going to make some kind of doodle of a rectangular prism. I want to say I even referenced that this problem's based on the physical principle Archimedes figured out that if you submerge a body in water, you can indirectly measure its volume. So it was 10 total, but you only filled it to 4, but then when you put the toy in it, it goes up to 6.6. The bottom of the base is an 8x6 rectangle. And I want to say I went ahead and did 8 times 6 was 48 for the bottom, and then started talking about how the height would affect the volume. So a right rectangular prism is basically like a stack of rectangles. And so at first, the volume is 48 times 4 is 192. But then with the toy soldier, the height of the water goes up to 6.6. So you would do 48 times 6.6 now. And the volume goes up to 316.8. And that difference in volume would have to be the volume of the toy soldier. So you're going to want to subtract that. And, it's like 317 subtract 192. Oh, I just punched it in the calculator. I was going to say it's in the vicinity of 120-ish. When you glance at the answer choices, only one choice is that low anyway, so it has to be A. 46 is another geometry volume question, potentially, from kind of looking at it. A box in the shape of a cube has an interior side length of 18 inches and is used to ship a right circular cylinder with a radius of 6 inches and a height of 12 inches. The interior of the box not occupied by the cylinder is filled with packing material. Which of the following numerical expressions gives the number of cubic inches of the box filled with the packing material? So this problem is looking for the difference in volume between this cardboard box that's a cube, so it's 18 by 18 by 18, and a cylinder. And I start to draw a bird's eye view of the cylinder inside of the box, and then I decide I don't like it very much, and I might even scribble it out here in a second if I remember right. It's worth mentioning that the volume of the cardboard box would be 18 cubed, and so 3 of the choices start with 18 cubed, so it has to be one of those bottom 3. And then you're subtracting off the area of the cylinder. And a cylinder is like a stack of circles. So if we can find the area of one of the circles and multiply it by how tall the stack is, we'll know what to subtract off. And it's important to remember that if you look at the answer choices, you're not actually finding numbers for any of these. You're just finding the one that has the right form. And so the area of the circles are pi r squared, and the radius was 6 according to the problem. So I'm liking the one with the pi 6 squared, and the stack of circles was 12 inches tall. So that's why it's going to have to end up being J. Looks like maybe I took too long to explain this one, or maybe I didn't take long enough to explain it this time. Oh, you all might be finally deciding it's J. I turned it sideways because I want you to be able to more clearly see the way it's written in the book, because I'm filming these with the iPad and an Osmo, and the stuff that's further away from the base of the Osmo is harder to read. 47. A room has a rectangular floor that is 15 feet by 21 feet. What is the area of the floor in square yards? It's important on a problem like this. You might be wondering, why is this number 47? It's because they want you to do a conversion of feet to yards in the process of finding the area, and it's going to be easy for people to goof up. It is one of the few conversions you have to know by heart for the ACT. They expect everyone to know that 3 feet is 1 yard. So you really want to start this problem by converting the feet to yards. So 15 divided by 3 is 5. So I'm going to cross that off and change it to 5 yards. Cross that off, change it to 7 yards. 7 times 5 is 35, so it would be 35 square yards, which is choice B. 48, ABC cabs and Terry taxi cabs both have an initial fare of a whole number of dollars for one passenger. The fare increases a whole number of dollars at each whole number of miles traveled. The graphs below show the one passenger fares in dollars for both cab companies for trips up to 6 miles. When the fares of the two cab companies are compared, what is the cheaper fare for a 5-mile trip? They're really just trying to scare you with all these words and a graph that's potentially unfamiliar. These are examples of what is often called a step function because the pieces of the functions look like the treads on a staircase. And you're just kind of walking up. It's basically rounding. The whole bit about increases the whole number of dollars for a whole number of miles. So all you really need to do to compare the 5-mile trip is read each graph. You start at 5 on the x-axis, which is labeled miles, and you go up to the graph, and you notice that you don't want to stop at the open end point. You want to keep going to the closed end point. And then if I were doing this on the piece of paper, I would slide over, probably draw the line, and you'd see that it looks like it's 12. Again, I'm not actually writing in the book because I was afraid I might mess up and have to re-record. And I did mess up, and I am having to re-record, but I'm just recording the voice. So if I had written in the book, it would be okay. All this is the part where I remembered I should probably remind you which version of the book that I have. And this is the 2018-2019 Preparing for the ACT Test. It's distributed freely. It's probably available online as a PDF with little effort on your part if you are wanting to play along. You go to 5 miles on the other graph, and again, you go to the closed end point, and it looks like it's lining up with $9. And they didn't want the difference in the fares. They just wanted to know which one was cheaper. And so the answer is going to be the $9. (49) The graph of a function y equals f of x consists of 3 line segments. The graph and the coordinates at the endpoints of the 3 line segments are shown below in the standard xy coordinate plane. Again, the ACT will always describe it like that just to soak up a little extra time. I don't think there's anything there that's not already in the picture, so I'll continue. What is the area in square coordinate units of the region bounded by the graph of y equals f of x, the positive y-axis and the positive x-axis? And they're hoping this kind of scares you because you're like finding the area under the graph. And if you've had a lot of math, that's actually a calculus question, but this isn't really a calculus question. You got to decide how to divide up the shape to make an effort to find that area that I marked with like the diagonal slash lines. And you know, maybe you do it like that. Or maybe you decide that it would be easier to cut it up differently and just do like a rectangle and a triangle and kind of get rid of that middle line. And I decide that's what I'm going to do. I'm going to find the area of that first triangle. I'm going to find the area of the rectangle. I'm going to find the area of that second triangle. You're going to want to, like, again, if you're doing this in the book, it would be maybe more easy, but I'm going to carefully copy over the coordinates so that I can begin to think about how the dimensions line up in this problem in terms of lengths and widths. By doing it this way, you only need to know the area of a rectangle, which almost everyone knows, and the area of right triangles, and right triangles are half of rectangles. And so it's like just finding the area of a rectangle and then cutting it in half, which is why the formula is 1/2 base times height, or base times height divided by 2. You look at the x's and y coordinates and you decide that that little triangle at the top, along the bottom, has a horizontal piece of 2, because it goes from 0 to 2 for x coordinate, but for the y coordinate, it goes from 4 down to 3, so that's a change of 1. And so that little triangle's area is just 1/2 of 2 times 1, or just 1. And then if it had been like, the problem would have been easier if they'd given you graph grid. You would have attempted to count the graph grid blocks. And for that piece, there would have been like part of a block shaded, and then the block above it would have a little bit shaded, and it would just so happen that the two together would make a whole block. The rectangle is from 0 to 3 for x and 0 to 3 for y. So it's actually a 3 by 3 square, so its area is 9. And then the other triangle goes from an x-coordinate of 3 to an x-coordinate of 5. So I'm going to put a 2 along the bottom. But it's from 0 to 3 tall, so it's going to be 3 along the other side. So it's going to be 1/2 of 2 times 3, or 1/2 of 6. So you end up with an area of 3, which is a total area of 13, so it's choice B. Problem 50 actually ends up requiring a little bit of algebraic manipulation, and there might be an easier way to do the problem than I thought of in that moment. The sum of two positive numbers is 151. The lesser number is 19 more than the square root of the greater number. So I decided to just call the numbers x and y, and think of the smaller number as x. The smaller number, the lesser number, is 19 more than the square root of the greater number. So x would equal 19 plus the square root of y. And I point out that if you were doing this, square root of y would end up needing to be like a reasonably nice number. The question asked for what's the value of the greater number minus the lesser number. Oh, so I might have messed this one up. It would be y minus x, not x minus y. So anyway, I might have it wrong, but you would end up wanting to think about 19 plus square root of y from the second equation plus the y. I've substituted the second line into the top line. And you subtract the 19 off from the 151, and it's 132. So you need a number that when you add it to its square root, you get 132. And you end up deciding that that would have to be, with a little bit of guessing and checking, you need it to add up to 132. So like, I try 100. Like 100 has a nice square root. So 100 for y would have a square root of 10. But that would only add up to 110. So that's not right. But it was close. 121 would have a square root of 11, and that would add up to 132. So y has to be 121. 121 for y would have a square root of 11, and 19 plus 11 is 30. And 121 minus 30 is 91. So the correct answer, I end up doing the subtraction in the correct order and still getting the right number, but I really should have had y minus x instead of x minus y. I just got away with it. So in the next video, we'll look at the last 10 math questions. And, you're just like this video, that number 50 took quite a bit of manipulation, but there were also 2 or 3 in that set of 10 problems where if you were able to read the question correctly, you didn't actually even have to be able to do that very, very complicated math to be able to get the answer. And so when you spend about 50 minutes on the first 40 questions, you're really spending 5 minutes maybe scanning through the last 10 or 15 that maybe you haven't tried, looking for a couple that look easy to try. And, that's not something that's easy to do. I'm able to do it since I'm a high school math teacher. But it's just, test taking strategy of being sure to spend the time on problems you actually feel like you're doing a good job of getting done. Thanks. Bye.